Good morning, everyone, and welcome to our live coverage of the latest mission from French Guiana and Europe's spaceport. I'm Will Robinson-Smith, reporter with Spaceflight Now. So good to be with you as we're covering the second launch attempt of the Ariane 6 rocket following a scrub that happened on Monday, March 3rd. Now, there was a ground systems issue that caused the delay of this launch, but as you can see just to my right, now bring it up full screen, you have the Ariane 6 rocket back at the pad. Ariane Space reports that both the vehicle and the payload on board are in good health as they are proceeding towards a liftoff for an instantaneous launch window, same as the last time at 1:24 p.m. That's 1:24 p.m. Kourou time, 11:24 a.m. Eastern, 16:24 UTC for our friends joining around the world. As we get rolling with our launch coverage, we are expecting to be joined hopefully in just a little bit as the launch progresses by our friend and reporter Frederic Castel. He is on his way to the European Space Agency headquarters there in France as we speak. Time now T-minus 46 minutes, 5 seconds and counting to the planned liftoff. As we're getting things rolling with today's Ariane 6 launch coverage, want to welcome those joining with us live right now. If you haven't already, be sure to click that like button, allow some more folks to find their way into this live launch coverage as we continue to roll along through the countdown. Also want to thank Stephen Young for running the technical operations of the broadcast. And to our moderators, I see Rick Donner joining us right now. I know Callistia Lee's been helping us over on Launchpad Live this morning. Appreciate the both of you being with us today. These live launch opportunities, of course, are made possible thanks to our wonderful channel members. So thanks to folks like the Rocket Girl, the Russian Floof Cat, and many others for supporting us in our coverage. Channel membership comes with a number of perks, including discounts at our online shop, that is shop.spaceflightnow.com, access to our members-only video here on YouTube, access to our members-only Discord server, and of course the ability to watch all of our live launch liftoff moments from here in Florida in 4K. Last but not least, if you have a comment or question about this mission and your comment or question is appropriate to be read as part of our broadcast, you can use the YouTube Super Chat feature. And not only will you be giving us some interesting things to talk about as we cruise on through the count, but you'll also be supporting what we do here at Spaceflight Now, and that is always greatly appreciated. As you can see from our live pictures coming to us from Europe's spaceport in French Guiana, a bit overcast there at the launch pad. Presumably, as is the case with all launches, they are keeping a close eye on the weather, but hopefully it won't be an impediment to a liftoff today. They'll be watching when we get some more information on the big board. On board this rocket, which is the first commercial flight for an Ariane 6 rocket, is a French military satellite, the Optical Space Component, or Composante Spatiale Optique, CSO-3 satellite. This is the third and final of a trio of satellites planned for this low Earth orbit constellation. We'll have more on the satellite and the launch as we, of course, continue on through the countdown today. Of course, this flight is not the only thing happening in the realm of space flight and launches and landings. It is quite a busy day, somehow even busier today than the last time we brought you live coverage of the launch attempt of the Ariane 6 rocket, since, as They would have it once again. We are also counting down towards the planned launch of SpaceX's next suborbital flight test for its Starship rocket. That's coming up down at Starbase in southern Texas, where the rocket has been fully stacked once again. And we're trending towards the clearing part of the day when all the cars will be removed from the area, and of course pad clear not too long after that. Sandwiched in the middle of all of that, though, to make this day even more exciting and interesting to cover for space fans and enthusiasts around the world, of course, is the second landing attempt by the Houston-based company Intuitive Machines, cruising towards a lunar landing at a site called Mons Mouton, which is near the south pole of the moon. Set to land a little bit after noon Eastern time today. So, of course, we're tracking the progress of the Nova C lander called Athena. If successful, it would be the second time that Intuitive Machines has landed one of its Nova C class landers on the lunar surface. So lots to track, lots to cover for you today, and we appreciate you all being with us as we cover it from tip to tail. Bringing things back here to French Guiana and the launch of the Ariane 6 rocket, let's go ahead and step through the countdown timeline for an Ariane 6 rocket. About T-minus 9 hours is when they perform a weather check and the gantry is removed. That's followed up by the mobile gantry removal, which back during the first attempt happened around 2 a.m. on Monday morning, local time. Of course, there's one more weather check before fueling actually begins. That comes around T-minus 5 hours and 40 minutes. If the go-ahead is given, then the chill down of liquid oxygen on the upper stage begins. That's followed about 20 minutes after by chill down and then liquid hydrogen loading on the Ariane 6 upper stage. Fueling continues about an hour later with the booster fueling. Starts at about T-minus 4 hours and 9 minutes with the chill and loading of liquid hydrogen on the booster stage, followed by same process, chill and loading of liquid oxygen on the booster. A couple more weather checks happen at the T-minus 20 and 10 minutes respectively. The synchronized sequence begins about 5 minutes before liftoff. The upper stage LOX tank is topped off at T-minus 4 minutes and 50 seconds. That's followed by booster stage LOX at 4 minutes and 18 seconds. Finally, booster hydrogen topping wraps up just before the 4-minute mark. That's followed by the last step in the fueling process, the upper stage hydrogen tank topping at T-minus 3 minutes and 15 seconds. Engine ignition on the booster happens 7 seconds before liftoff. And hopefully we'll get through this whole process and we'll see the ascent of just the second rocket in the Ariane 6 program. This particular type of Ariane rocket features 2 solid rocket motors. It has the option of flying with either 2 or 4 of these strap-on boosters. Time now, T-minus 38 minutes and counting. Mentioned the rollback of the mobile gantry that happened around 2 a.m. local time prior to the planned launch on Monday, March 3rd. Here's a couple of pictures taken by Ariane Space of that retreat of the mobile gantry, as we'll be hopefully joined by Frederic Castell here in just a little bit. He can recount what the process is like down there on the ground of seeing the mobile gantry withdrawn. For those here in Florida who may have seen it, it's somewhat of a similar process for the Delta IV rockets. If you recall the final flight of a Delta IV Heavy last year, when we saw the mobile gantry roll back away from that rocket before its ascent. Similar process here with the Ariane 6. Now T minus 36 minutes, 15 seconds and counting. About 15 minutes away from the next planned weather check to proceed. Time now T minus 34 minutes, 34 seconds and counting. Here's an artist rendering of what the satellite on board this particular rocket looks like when it's in its on-orbit configuration. As mentioned, this is the CSO-3 satellite. It will join the other two that are part of the constellation. CSO-1, which launched back on December 19th of 2018, and CSO-2, which launched on December 29th of 2020. Working in concert, these three satellites help provide defense and reconnaissance information for the French Air and Space Forces Space Command.
Est-ce que vous pouvez vous mettre en marche mon iPad, s'il vous plaît? Thank you.
And we're currently T minus 25 minutes, 12 seconds and counting to the planned liftoff of the Ariane 6 rocket. Taking a live look inside the control center there in French Guiana. And we're also, as you can see, in the box beneath me, joined by our friend and fellow reporter, Mr. Frederic Castel. Good to see you again, sir. How are you?
I'm fine. Good to see you. I'm not anymore in Kourou, as you can see.
No, not in Kourou anymore, but you were at the European Space Agency headquarters there, right?
Exactly. Well, a lot of security makes the connections difficult, but it's working somehow.
And so, obviously there was a bit of a stand down from the last time we spoke in the last launch attempt, but rockets back at the pad, teams are spun up again for another launch attempt. I mean, you mentioned that there might be a stand down of at least a few days. What have teams been up to in the intervening time from, what you've been able to suss out from Ariane Space?
So, what we heard from, I mean, you have three entities working on the Ariane 6. Of course, you have Ariane Space people, but you have CNES people, which is the French Space Agency. You have also ESA. You have a lot of different teams. About more than 500 people are required to be working on Ariane 6 to make it ready for launch. So first, they had to save it and to have all the tanks empty and to be sure that everything is okay. It's only the second launch of Ariane 6. It's a brand new rocket. It's a massive rocket, pretty big. Not as big as Starship, obviously, but for Europe, it's the biggest one in the game. And they had to stop the last time at the very last moment. They saw it on the screen that something was wrong on the ground, and they could even see. I spoke with engineers in Kourou, and they told me that they saw that there was a problem of valve, and a huge valve of more than 150 kilos, almost 300 pounds on the ground, which was providing fuel to the first stage. So they had to replace some parts. Good, the parts were there, were in French Guiana, because French Guiana is in the jungle almost. So you don't have everything handy, but they had it. And they made the rocket, the launcher ready again, and everything is good at this point.
Yeah, it seems like it's usually a valve somewhere that causes a ground systems issue like this. So glad to hear that it was something that was able to be resolved fairly expeditiously. And, looking at the clock, you're T-minus 22 minutes, 10 seconds to liftoff. So we've already progressed past the point in which they had to scrub last go around. So things already going better than that first time that they had spun up. Like we mentioned when we brought you in, you're at the European Space Agency headquarters, one of the main partners in this venture. But this is the first time that ESA is not explicitly in the driver's seat of this launch. It's really Ariane Space, right, that's taking the reins of this. Can you give our audience a sense of the big key difference between first inaugural launch when it was mostly ESA leading the charge to now this time around?
Yes, ESA is, of course, the European Space Agency for all Europe. They are in charge of the strategy of the launchers and access to space. They are developing with the industry the different launchers. They had a breakdown because it took several years, 2 to 3 years, to get Ariane 6 ready. And now, after the first launch, the test launch, which was in last July, things worked pretty well. It was planned that, of course, at the second launch, that becomes what they call a commercial launch. The Ministry of Defense of France, which is launching a military satellite, observatory satellite. And so now just ESA is part, of course, its overview, but it's not in charge of this launch. This launch is under the responsibility of Ariane Space, which is the operator and the commercial operator to sell the services. And of course, they have the help of CNES and all the teams in Kourou, including a lot of security. Like for every launch, they have hundreds of special military in the jungle to be sure that there is no problem on terrorist attack. And this time they even brought some 3 Rafale aircraft, which are fighter aircraft, state of the art in France, with some AWACS and refueling flight and about 300 special pilots and French Air Force people. That's where we are now.
And as we're now less than 20 minutes as well to the planned liftoff, we're going to let Frederick take care of some technical issues in the background,
Yep.
Do a little more setup there. We'll come back to him in just a moment here. Want to bring in this mission animation in just a second. That'll give you an overview of what we were talking about a little bit earlier in the broadcast of how this satellite, the CSO-3, is going to be working in concert with the other two that are currently on orbit, the CSO-1 and CSO-2. As you can see, they operate in a low Earth orbit environment. As I mentioned, CSO-1 has been there since 2018. Its counterpart, CSO-2, since 2020. And CSO-3, once it joins the other two on orbit, it will essentially provide very similar coverage as CSO-1, which is designed to, as officials describe it, allow for coverage, acquisition of theaters of operations, and revisit capability identification that will allow the CSO-2 satellite to really focus on getting high quality, high resolution imagery and do its analytical work with high precision. So that's how these 3 satellites will be working in concert with one another. And you're seeing, again, an artist's rendering in this animation for how that works. Now currently T minus 16 minutes, 36 seconds and counting. Assuming all is going well with the countdown timeline here, we're just about 6 minutes away from the next weather evaluation, as of course is the case with all launches. Ariane Space is keeping a close eye on weather conditions prior to liftoff. T minus 15 minutes, 35 seconds and counting. As I mentioned, the Ariane 6 that's set to launch today is flying in a Ariane 62 configuration. Here's an illustration of the differences between the various versions of an Ariane 6 that can launch. It's also using the shorter of the available payload fairings that are available to it. As you can see in the lower left-hand corner of your screen, shows you from a bottom-up view what the configuration of an Ariane 6.2 versus an Ariane 6.4 will look like. We're expecting to see the launch of an Ariane 6.4 rocket presumably later this year. This graphic designed by the European Space Agency. This is a look inside the control center at Kourou in French Guiana as operators are continuing to track towards a liftoff of this rocket coming up here in just a little more than 14 minutes. As Frederick was mentioning, security, of course, remaining tight on this launch site. You may have noticed the helicopter that flew by in the background just a moment or two ago. Time now T minus 12 minutes, 27 seconds and counting. Let's go ahead and review the launch timeline before we see liftoff of this Ariane 6 rocket. Assuming everything progresses smoothly over the course of the next 12 minutes and 12 seconds, we'll see the ignition of the Vulcain main engine coming up at T minus 7 seconds. Then following liftoff, a little more than 2 minutes into flight, the booster separation will occur. I'll be followed at T plus 4 minutes and 30 seconds by the separation of the payload fairings that are currently encapsulating the CSO-3 satellite. Main engine cutoff comes up at T plus 7 minutes and 35 seconds, followed by upper stage separation about 10 seconds after that. The Vinci upper stage engine will then ignite at T plus 7 minutes and 54 seconds for its first burn. Unfortunately, Arianespace didn't share ahead of the launch how long each of these upper stage burns last. The second burn will happen at T plus 56 minutes and 21 seconds into the flight, allowing for the satellite to be deployed at T plus 1 hour, 6 minutes post liftoff. Finally, there will be a deorbit burn of the upper stage at the 2-hour mark, helping to decrease the chance of creating any unnecessary space debris. For those familiar, obviously, with Falcon 9 rocket launch is a similar mode of operation.
Sarò in diretto in qualche minuto.
Time now, T minus 8 minutes, 30 seconds and counting, bringing back our friend Frederic Castell. They're in the European Space Agency headquarters with less than 8.5 minutes to go, Frederic. Presumably they've gone through the final weather check. What's kind of these last final minutes, what is that process like? You were, obviously covering the inaugural launch of Ariane 6 with us. What's happening in these final moments now?
In this final moment, as many launches also in the States, most of the countdown is automatic, but you have about 50 to 60 engineers and managers, launch managers, who are looking at the screen to see if all the data, all the numbers are good. And of course, we have also a big screen where we have the different key point where we can see the green light. Sometimes a red can come out even before the experts and the managers see it on the screen, because it's an automatic mode where there is a no-go. But the last time, for example, they saw that something was wrong with the flow, and they saw that a problem was converging to something, and then the red came out, but they knew that the red would come in that case. So everything is calm from what I hear now, and the countdown is processing smoothly for a very important launch. I remind you probably underlined it, is that it's the second launch of a new rocket, Ariane 6, and as we know, a launcher becomes really reliable and safe after a few launches, more than one for sure. And so people, of course, are tense and hope to everything will be working fine. And on the other side, of course, the defense people, the French military people, who have this big third spy satellite, if you can say spy. It's of course it's just a huge camera which can see a lot of things on the ground with colors day and night, and analyze it, and they share it with 8 countries in Europe. It's also very difficult. There is a challenge that they have to launch because it's an orbital launch, and it has to be geosynchronous. It has to follow exactly the light of the sun to observe and to work. They have no windows. It means they have to launch it exactly at the second. If there is any bug, any little problem, they scrub and they will start again next day or the next day. That's where we are.
And obviously leaning into the importance of getting this rocket off the ground and seeing it launch successfully is key in really building confidence in this as a launch vehicle moving forward, both from government use as well as commercial use. If there were to be another anomaly, say on par with what we saw last time, or in a worst case scenario, something that is more troublesome than that, how big of a deal would that really be on this program? Last time we mentioned in the Monday Scrub launch broadcast, you said there's not another customer lined up to launch until August. So would it really be that big of an issue since there's that long gap, or would it really be problematic if there were to be an anomaly on this flight?
Of course, if there is a huge anomaly and if they lose the launcher, it happened on Ariane 5 on the first launch. They lost the key launcher about the same mass years ago, more than 20 years ago. Of course, it would be a big blow because already Ariane 6 is 3 years late in its development. And in the meantime, things have changed so much. Europe used to have 3 types of rockets. They used to have not only Ariane 5, which was an outstanding launcher, pretty costly but very efficient. Then it stopped because this was the last one when Ariane 6 should have taken over, and it wasn't ready. They had as a backup a bit smaller for mid-sized satellite, like this one, the Soyuz, the Russian Soyuz. Of course, with the war in Ukraine, the Soyuz out of the game, and they had the little launcher called Vega, which had also its own problem, but which is flying and which is operational now. But of course, it would be a big problem. But the determination of Europe is total. It means that even if they had a major failure, losing the rocket, this program would keep follow because Europe wants its autonomous access to space, and especially right now where Europe has a new situation with a new relationship with its US ally. Autonomy is a key word everywhere in space, military, politics. Everybody in Europe is following closely what's going on, not only in space, but also in the States.
Well, speaking of following things closely, we're now less than 3 minutes to the planned liftoff of this rocket, getting right down to it. We're within the automated sequence getting started, as we've been talking about, speaking of autonomy and autonomous systems. Coming up the next milestones we're looking for are just the engine ignition is really the last big thing that's going to happen here, coming up at T-minus 7 minutes. At this point, the rocket is fully topped off with all of its liquid oxygen and liquid hydrogen, and the vehicle appears to be in good health, Frederick. So we are poised to see this launch coming up here in just 2.5 minutes now.
Yeah, they have even a green light from the CNES in Toulouse, in France. You have already people who are in charge of taking care of the satellites once in orbit. They are checking that the baby, if we can say, quote unquote, baby, is perfectly healthy to be ready for launch. And that the CNES is the French Space Agency in Toulouse, which is another big city in France, where they have been launching more than 1,000 satellites and put it in orbit with the previous Ariane rockets.
And as you can see, a really nice shot of the main engine there at the pad. We're now cruising into the final 2 minutes of the count as we prepare to see this first commercial flight of an Ariane 6 rocket. And we're actually going to go ahead and step back on our commentary in the lead up to launch. We're going to go ahead and listen in with all of you into the final minute and a half of the countdown. And we'll be back with our commentary as the mission progresses on the other side of liftoff.
Perfect.
We're getting close now to launch.
On est prêt.
À tous de DDO, attention pour moins d'une minute. Top, à 0, moins une minute.
We are 1 minute to launch. Best wishes now to all the teams who have been working so hard for today. Good luck, everyone.
Bon voyage, CSO3 on Ariane 6.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage de ESR et décollage. La propulsion est nominale. Pilotage calme.
We have lifted off. Ariane 6 and CSO3 have started their
Propulsion
journey.
nominale.
He's telling us that the propulsion is normal. We are looking here at our cameras, onboard cameras.
Tous les paramètres à
looking
bord sont
down.
nominaux.
He's telling us that everything is going normally. I believe, David, we're looking down here at one of the boosters.
Yes, that's right. These are the onboard cameras. We have a
Propulsion
cloudy day
nominale.
today, so you can see the rocket going through the clouds.
Indeed, we've already broken the sound barrier. We
Pilotage
have.
calme, trajectoire nominale, paramètres à bord nominaux.
He's telling us that everything's going according to plan. David, we can hear our rocket coming over the Jupiter Mission Control Center about 16 kilometers from that pad. It takes time for the noise to get to us, the rumble, as it's sometimes known in the jungle.
That's right, and we can feel now the vibrations of the boosters coming up to us 15
propulsion est
kilometers
nominale.
away.
Indeed, and it's those boosters which are doing all the work, even though we have switched on the engine on the Vulcan engine on the main stage. The boosters, well, their job is to literally boost us away from our
Trajectoire
planet's
nominale, paramètres à
gravity.
bord nominaux.
That's right. It's the boosters are providing more than 85% of the more than 800 tons that we need to take off, and these boosters will burn its 2 times 142 tons of
Pilotage calme.
propellant during a bit more than 2 minutes. And after that, we will have lost about 70% of the mass that we had at the time of liftoff.
That's the name of the game. The lighter we are, of course, the faster we go. Those boosters scheduled to
Propulsion nominale.
detach in a matter of seconds. Seeing our images here on the live cameras
Séparation des ESR.
just a few seconds after the event, but we have confirmation that those have actually separated. As I
Propulsion
said,
nominale.
the images are coming to us for technical reasons, just with a very slight delay. And he's telling us that the propulsion is nominal. And there we go. That's what it looks like in space. Those boosters falling away. The trajectory on the right-hand side of our screen. the
Trajectoire
green-
nominale, paramètres à bord sont nominaux.
Everything's normal. The green line is the planned trajectory. The cross, indeed, is our actual position of our rocket. Our speed and altitude. David?
Yes, we're close to 100 kilometers now, and we're 150
La propulsion
kilometers
est nominale.
downrange from Kourou, and we have a speed now of 1.7 kilometers per second and increasing.
Per second, not
Per
per
second.
hour, per second. So that's the kind of speeds we're going to be heading up towards. We'll be getting to 8 kilometers per second. Look at the images on the bottom right of your screen. That is the big main stage, the tank of fuel at the very front of sort of pointy section, if you like, is our fairing with our satellite inside. It's got a number of different jobs. It's protecting the satellite, isn't it?
Right, it protects the satellite while it's on the ground against dust, humidity, on any kind of pollution. Then it protects the satellite during the launch itself, the liftoff, because there is a lot of acoustic noise.
Trajectoire nominale.
And finally, during the atmosphere part, then it protects it against the air friction and the extreme heat that is generated by this friction.
So our satellite nice and comfortable up there in first class inside the fairing, having started its journey. That fairing will remain there for another few seconds. And of course, as we saw earlier, David, you were explaining it's made in two halves.
That's right, and this is the onboard camera showing the two halves of the fairing that will separate.
Séparation coiffe.
We have confirmation that the fairing has separated, and we'll be seeing those, hopefully, those images on our onboard camera. It actually, as it separates, David, it flexes. It's called the breathing mode. It's very specially designed to do that.
Yes, that's right. The breathing mode. Here we go. We have the separation and the breathing mode through the onboard cameras. This breathing mode is this movement of the two halves that happens due to the forces of the pyrotechnic separation and then the ejection forces and the flexibility of the structure.
Looking back down at our planet now, you can see that thin blue line.
La propulsion est nominale.
The atmosphere of our Earth.
And now a little more than 6.5 minutes into flight. So far, seemingly a picture-perfect ascent, Frederick. We're just about a minute away from main engine cutoff, and that'll be followed quickly by stage separation and then the upper stage engine ignition. Before we see those events, just briefly in about 15 seconds, your top mind thoughts on this first part of ascent.
Of course, there is a very big relief, although we are far from the end of the mission. It will take about an hour to have the satellite released in orbit. But in French Guiana, I got some feedback of the people in charge of the launch. I was pretty happy because everything was perfect and nominal. Of course, there are a lot less VIPs and defense general and people from all around Europe because they had to fly back to Europe at this point. But a few officials are there and they're happy. But of course, we never know. The mission, it takes time to be fulfilled. And we follow all the data and everybody is happy, but very concentrated to see what's going on in the next 60 minutes.
Cautiously optimistic, of course, as we're approaching the next big mission milestone, which is main engine cutoff, coming up here in about 10-ish seconds. Let's go ahead and listen in as we see main engine cutoff, stage separation, and engine ignition.
And we should be able to see it on the onboard cameras.
You can see on the bottom right is you can see our satellite CSO3 attached to the front of the rocket, at the top of the rocket.
Paramètres à bord nominaux.
Getting close now to the next event. We call it MECO, main engine cutoff.
Yep.
Extinction Vulcain.
And we have confirmation that the engine has switched off.
Séparation LLPM.
And we have confirmation that the main stage
Allumage
has...
Vinci. Fin de mission sauvegarde.
has separated, and the upper stage has switched its engine on, and that's what it looks like up there in space with our onboard cameras. That great big
Propulsion
tank
nominale.
of propellant. It's burnt its fuel. It's falling back down to Earth. So, David, the upper stage has taken the wheel. It's a little bit like a
Pilotage
fancy
calme.
orbital taxi driver, because its job is to drop off its passengers in space. Today we just have one passenger. And we've got a new engine for the upper stage. It's called the
La trajectoire est
Vinci
nominale.
engine.
Yes, the Vinci engine is one of the big innovations of Ariane 6. It provides the mission flexibility. It is designed to switch on and off up to 4 times, allowing to take different passengers to different orbits. It's the
Première
first
allumage
Ariane
APU.
rocket that has a cryogenic engine with this reignition capability. For the mission today, we will use the engine twice to deliver CSO3 to its
Propulsion
orbit.
nominale.
And after that, we will use a third burn of the engine to deorbit the upper stage.
And we had the range operation.
Can you hear me, Steve?
Yes, bringing Frederick back in. Good stage separation, a good first burn start from the upper stage Vinci engine. Obviously, things are progressing as engineers were expecting at this point, Frederick.
It's quite nominal. It's what all the controllers are saying. And of course, now it's also a very important step to see how the upper stage, the Vinci stage will work. It's very important. It's almost as important as the first stage, because it's really the new part of the rocket compared to Ariane 5. It has the possibility to ignite several times, and so to put, as they said in the official comments, that it can carry satellites on different orbits, on different altitude, and that's a new step. That's only Ariane 6 which has this flexibility. So it's very important, and we'll see also, if we remember in July, the launch of the test launch, they had no real payload on board. It was just a neutral mass on the rocket. Everything worked well, but at the last moment, when they were in orbit, they wanted to deorbit the upper stage, because it's the rule now in Europe and especially in France. It's called space law. They had a problem with the APU, the auxiliary power unit, which had a little failure, and they couldn't do exactly the job to deorbit. So they worked on it. It was not a big work, but it took a few months to be sure that it worked. But then, as the managers told me, and the ESA managers told me, it can be only tested in space. So we'll see if everything works well with the APU to make the second ignition. The first ignition, of course, is to put the payload, the 3.5 ton satellite on its orbit, about 800 kilometers high, and after to deorbit this upper stage, and that has to be work and cannot be simulated on the ground.
And I believe it was the third burn of the Vinci engine, right, where they ran into some trouble and the ACU was not operating as intended.
Absolutely. Excuse me. Yes, exactly. It was the final ignition that didn't work well, and we could see it live. By the way, we could see the trajectory had a strange design, and all the media say, "What's going on here?" And we didn't have an answer right away, but then they found out exactly what happened with this APU. So we'll see what's going on in about a little bit less than an hour now, after the release of the military observation satellite.
And of course, that third burn of the APU and the Vinci engine, that'll be for the deorbiting of the upper stage this go around, as opposed to, I believe last time it was in preparation for deployment of some additional payloads. So not quite as impactful if for some reason there's an issue with that third burn this time as far as what you're deploying on orbit, but important, I would hazard to stress, since a big part of your space program is to be as responsible in orbit as possible and make sure you're deorbiting these upper stages.
Thank you, Will, to remind. Yes, there was some test little payloads, and of course it couldn't work. They couldn't be released on the right orbit because of this APU failure. So it was a loss. It was not commercial payload, but of course the mission was not 100% successful, but it was a little bit less than 100%. I couldn't quantify exactly. So we'll see now if things are working. And by the way, of course, after this first launch, they spent months and months of analyzing to analyze all the data to be sure that the launcher, when there is a new launcher, all the space agencies, all the space operators analyze exactly every little detail to understand what's going on, how the hardware is behaving. And usually with the second flight, the third flight, they adjust, they improve, they try to have a better performance. That's a long work, which takes so many hundreds of engineers, not only in French Guiana, but especially in Europe, where this rocket is built by majorly by 10 countries, and the industry is very involved, especially Ariane Group, which is a group based next to Paris, which builds not only the Ariane 5, but also M51, which is a ballistic missile for nuclear heads, which is a pure French product. It is not shared with Europe at this point, and is the same Ariane Group which develops Ariane 6 and M51. And of course, there are a lot of synergy between these two programs. One is fully classified, and the other one is civilian. And we see it working now.
So as this rocket program progresses into more and more of a regular launch cadence, as we talked about a little bit before liftoff, the European Space Agency was heavily involved, obviously, with both the development and execution of that mission, but is now starting to step a little bit back. Projecting forward with mission 3 and moving beyond that, Frédéric, how much involvement will ESA have in future missions, or will it really just be Ariane Space?
Excuse me, Will, can you repeat the question? Because there were some ESA people coming in and they
sure.
stopped the feed. I apologize.
Not at all. I was just asking, with the European Space Agency really having been the sort of main driving force behind the inaugural flight last year, stepping back a little bit, letting Ariane Space, really take the lead on this one. What is ESA's role moving forward with these Ariane 6 launches? Obviously, since there will be a balance of both government and commercial operations, what is their place at the table, as it were?
Yes, exactly. The agency, although they were handling totally the first launch, the test launch was in July, was under their responsibility. Once it worked, like we said earlier, Ariane Space took over. Of course, they still work with, you have ESA people in French Guiana, you have CNES people, the French Space Agency, you have the industry, of course, all that. They work together. And so what is doing ESA at this point? They are not involved directly with this mission, but they have to check that everything is fine. And in the meantime, they are working to improve Ariane 6. In about a year, Ariane 6 will have some new boosters to have more power to put more heavier payloads in orbit, especially the Kuiper constellation, where they have 18 orders from Kuiper, which is the constellation which belongs to Amazon, American company. It's a huge order, and they will, of course, use a more powerful Ariane 6 to put more payloads, more satellites, more Kuiper satellite in that case, in orbit. So it's a key development, and that's under the responsibility of ESA until it's operational and working well. And then, if it's the case, Ariane 6 will, ESA people will give over the work to Ariane Space and CNES. Also, ESA is working on the future, on the next decade, to see they're trying to help a lot of the private industry, like a little bit in the States, to have small launchers developed by the private company. And you have a lot of startups in Europe now, which are trying to have some small launchers, and hopefully these launchers will work. Some of them, perhaps there's a dozen main program on that. Some of them will succeed, some others perhaps will not. And the best one will perhaps grow to more powerful and bigger launcher. But we speak about the next decade, and even ESA is also working, but that's also on next decade to have some kind of launcher where you can reuse at least the first stage, like we see it with SpaceX and a few other companies in the world.
And we'll come back to that part of the conversation. Just want to note that we've seen the first burn conclude here on the upper stage of the Ariane 6 rocket. It will now coast for some time. The next burn, the second and final burn prior to the payload deployments coming up here at T plus 56 minutes and 21 seconds. So taking a look now at the trajectory, the track of the mission here, as we're a little bit more than 20 minutes into the flight. So got about 35 and a half minutes ahead of the second burn coming up here. As we continue to monitor this, Frederick, want to come back to that point you were just making a second ago about the entrance of a number of the smaller launchers around Europe and in various countries. You know, is the expectation that there will be any medium to large or heavy lift launch vehicles that would eventually be able to compete domestically with the Ariane 6, or is this really trying to just grow at a smaller launch market, a small launch market of small launchers, and leave the heavy lift work to the Ariane 6 and to Ariane Space?
For sure, they will keep Ariane 6 as long as possible, because that's the main workhorse for Europe. It replaces the Ariane 5. And on the long term, they know that they need to work on reusable rockets. We see a lot of managers speaking about that, and you have teams working on that, doing some research and some tests. But of course, that's a few years from now to have something operational. And on the small launchers, some also are trying to develop some reusable rocket. But at this point, they are still in development, in test, and we're waiting in the next couple of years the first flight of this rocket.
That'll certainly be exciting to follow. I'm sure a lot of folks in Europe are really interested to see, you know, these smaller launchers come online and the burgeoning launch environment there continue to grow.
Yeah, and if I may add, interestingly, in French Guiana, at the Guyana Space Center, the CNES, the French Space Agency, is working to have some smaller pads, to launch pad, which will be available to private companies, so they can test and even launch when they will be operational from French Guiana. That's the strategy, that's the general idea of development of the private sector. So we'll see what is working and what is not working, but the whole strategy is taking a new shape. And even if right now we have the Vega, which is a smaller launcher developed by Italy and handled by Italy directly, and Ariane 5. No more Soyuz, obviously, no more Russian Soyuz. And then will come in the game these new launchers. A lot of people are, of course, excited to see what's going on. And it's perhaps as active, dynamical. You see so many young engineers working in startups with a lot of energy, and they get some investment and some help from ESA, the European Space Agency, to develop their new vehicle for launching smaller payloads.
I believe the process of getting to the next Vega C launch is already in the works, if I'm not mistaken, right? That's going to be the launch of, was it the biomass satellite? Is that next up for Vega C?
Yes, exactly. That's the next big ESA mission in a few months that will be on Vega, and it's a very important science mission to study, of course, the biomass. And it will be very interesting because next to the French, the Guiana Space Center, you have Amazonia. When you're in Kourou, from any road or the launch site, you can see the jungle, the huge jungle, which starts the Amazonia up south up to Brazil. So it's a big subject there to see if science can help to follow what's going on with biomass and all the chemical and temperature exchanges with the floor. Okay.
Yeah. Yeah, for those obviously tracking the environmental changes, that'll be an important one to see on orbit, and
Yeah.
lots of science and lots of observations coming from that. So it's especially exciting to see that get online in the not too distant future.
Well, if I may say, also an interesting point is that a lot of people were complaining that why it took so long I come back to Ariane 6 launch today. Why it took so long between early July and now to launch the second Ariane 6. As we said earlier, of course, they need to check every part to be sure that the new launcher and all its complex systems are working properly. But also, when I said, because it should have been launched in December, and I said, what is the issue? Is it the APU failure in July? And they told me, no, in fact, it's not. We took our time because we don't have too many, the payloads are not ready for the next launch. The next Ariane 6 launch, even if they have a lot of launches planned, big backlog, with more than 30 launches of Ariane 6. The next payload to be ready will be ready only in August. So they said we didn't have to run to be ready for this launch. We could take our time to check everything, that everything is okay. And in any case, the next passenger, quote unquote, payload, of course, will be in August and not earlier. So there is time. But by the end of the year, the challenge is for Ariane Space and its partners to launch another 3 Ariane 6. So at the end of the year will be pretty busy in French Guiana because they want to launch at least on this first year of Ariane 6 to have 5 launches.
And as I recall in some of the pre-launch briefings ahead of the inaugural flight, it's around somewhere between 5 and 10 Ariane 6 launches is what they're aiming for annually, correct?
Absolutely. The ramp up is the big second challenge, is that they want to, of course, next year to go to 6, 7, 8 as soon as possible because the backlog just for Kuipers is pretty big. All the launches are reserved. It's not very easy for customer worldwide to have a launch on Ariane 6. Sometimes they should have to wait for 3 years to get a launch opportunity. Although Ariane Space said that in some cases they could add a launch in between. But first, of course, next year in 2026 and 2027, Ariane Space and its partners, it means ESA and the French Space Agency, has to prove that they can handle such rhythm of launches per year. But they are trying to get ready of that, and the Guyana Space Center now it's all almost all digital, and they hope to be able to launch within 3 days, perhaps not to Ariane 6, but an Ariane 6, and then switch, for example, to a Vega, thanks to this improvement, technical improvement, because now the French Guiana Space Center is aging. I've started with General de Gaulle in the 70s, and now it's a lot of things have to be replaced. It has been over time, but even more now that Ariane 6 is the state of the art in terms of classical launcher. I mean by classical launcher, non-reusable launchers.
Yeah, I think there's obviously been a continuous and progressing conversation about the value, importance, the practicality of switching from more legacy style launchers to reusable ones, what that means for those that are not designed to have reusability, and how much longer that they can exist in the same marketplace. As Falcon 9 continues on, we're seeing the progress even as soon as later on today with Starship and others in China that are working on reusability. So it'll be interesting to see what the rollout looks like in practicality in the European launch market.
Yes, and I have to add that in Europe there is a lot of pressure from politicians in France, but all around Europe, because they see the amazing rhythm of launch of SpaceX with Falcon 9, and the politicians who don't have any clue about how a rocket works, they come and they put pressure saying, okay, why it takes so much time to launch a rocket like Ariane 6? They can't figure out the complexity of a space program, and even in the States, as you know better than anybody, for the competitors of SpaceX, it's also quite difficult to have a big launcher which is operational. So there is a big in Europe. There is this big pressure from politicians, on the industry to say, okay, move on and go to reusable. But the strategy now of the space agencies around Europe, they know that they have to go one day or the other to reusable, because that's the future. We heard it from main managers, from the CNES, from the French Space Agency. We heard it from ESA people. But of course, when Ariane 6 was initiated, this program about 10 years ago by ESA and the CNES, the philosophy was not yet to have a reusable. We didn't have SpaceX and Falcon 9 all around to push to go to the next step. They thought that someday they would go to reusable, but they thought it would take several years, if not decades.
Just want to take a quick point in time here. We're currently T plus 31 minutes, 41 seconds and counting. The start of the next burn on the upper stage is a little more than, actually right about 14 minutes away from now, T plus 56 minutes and 21 seconds. So still a little bit yet to go on this coast phase. You're seeing the telemetry data there in the bottom right-hand corner of the screen. The visual of the Ariane 6 upper stage, obviously an artist rendering a digital representation of the orientation and position of that upper stage, but reflected through the telemetry data that's coming down to Ariane space. So a representation of what's happening in real time, but obviously there's no drone that's flying side by side. It's just a digital sampling.
Yep. So
one question I did have for you, Frederick, going back to the next launch of Ariane 6, you mentioned the time between the inaugural flight to now was really driven by them wanting to go through all the data and make sure they had a full understanding and everything was known going into this launch as much as could be. The next launch driven more by customer readiness. Do you expect there to be, as sort of in parallel with that, as deep of a dive and over as long of a, maybe not as long, obviously, but still a quite long period of review of the data on this one? Or do you think it'll be a fairly, assuming there aren't any great anomalies coming up today, a fairly simple review and understanding of what happened during this flight?
No, of course, if there is no anomaly, no failure, we have to remind that Ariane Space, French Space Agency, and ESA have been excellent developers of the Ariane program. Just to remind that during 25 years, the best launcher in the world, the best commercial launcher in the world, which had the majority of the market, was Ariane. So there is a know-how, there is an experience about launchers, because we reminded there was Ariane 4 and Ariane 5, where they had also failures, they recovered and they kept going. So they have a lot of experience. So if things are going well, the ramp up, the improvement, and the next flights will go faster and faster. But of course, for the second flight, perhaps the third flight, they are still very careful to check everything to see if there is any hiccups, any little problem, to be sure that the launcher has all its capabilities for the future. This launcher should be at least good enough for the commercial market for 10 years, even if it's not reusable. Also, I will underline that French Guiana, where we were a few days ago for the first attempt, is the best spaceport in the world. Why is it the best one? Because they can launch polar orbit like today with this military satellites which go on polar orbit, but they can launch also in geostationary orbit. So they can launch north or they can launch east at any moment. And compared to Kennedy Space Center or Cape Canaveral, they're only 2 degrees from the equator, which gives you a lot of more speed because of the rotation of the Earth, because you're almost at the equator, which is not the case of the other spaceport in the world. And finally, they don't have any hurricane. Hurricanes don't hit our Earth at this latitude, equatorial altitude. So weather is not usually a major issue. Of course, there can be some delays when there are too much wind or too much rain, but it's not a big issue in terms of spaceport, and that's an asset. And now, what was used to be a French space center, it's a European space center, and ESA, again, the European Space Agency, participate and invest a lot of means in with the CNES in French in the Guiana Space Center, which is the official name is the European Space Center.
Yeah, well, I will definitely grant you not having to worry about hurricanes is certainly a big plus for that spaceport. Not something to be easily overlooked, even with rockets that can stand outside through hurricane force winds, like we saw with the Artemis 1 mission, where they left the SLS rocket out of the pad during Hurricane Nicole, which thankfully didn't make a direct landfall right on top of the Space Coast, but the eye wall was pretty darn close, as I recalled. It was up in, for those familiar, Volusia County, which is just to the north of us here in Brevard, where the Kennedy Space Center is located. So, less than 80 miles up the coast. So not too far away. Certainly felt the hurricane force winds here in the Titusville, Cape Canaveral area. Thankfully, no structural damage to that rocket, but certainly it's an impediment for launch, and the knock-on effects of having to clean up the spaceport and make sure all of your ground systems are functioning correctly and everything is in working order, and obviously having your personnel being able to get back and access all the systems they need to post-hurricane is something to not be discounted. So a lack of that, certainly in summation, is a good thing.
Yep, exactly. Yeah, absolutely. So
we're going to go ahead and take just a brief pause here. We're currently plus 38 minutes, 8 seconds and counting. We've got a little more than 10 minutes to go before we reach the start of the next burn. So we'll be back with you with some additional commentary here in just a little bit. But of course, we'll keep the telemetry up at the bottom of your screen, and you can continue to follow visually the progress of the Ariane 6 upper stage with this rendering of what the upper stage is going through right now. And we'll be back with you. More commentary shortly. Time now T plus 46 minutes, 52 seconds on the Ariane 6 launch. As happens to be the case, this is one of those days where one big spaceflight event falls on top of another. And as we're monitoring and awaiting the second burn to begin here in the next now 9 minutes on the Ariane 6 upper stage, we're also keeping our eyes on what's going on down in Houston, Texas, where got a live look right now into the NOVA Mission Control Center from Intuitive Machines as teams are monitoring the final descent for the NOVA sea lander called Athena on the IM-2 mission. This is the second time in less than a week that a lander taking part in NASA's Commercial Lunar Payload Services, or CLPS program, is preparing to touch down on the moon's surface. Just a bit of happenstance that both of these events have coincided so close. And of course, we saw a good landing of Firefly Aerospace's Blue Ghost lunar lander midway through its operations on the moon's surface, working through some of its NASA payloads, including the Planet Vac and others. Intuitive Machines' Nova Sea lander features the Prime 1 mission suite, which includes the Trident drill and the M-Solo mass spectrometer, which will drill down a total of 1 meter into the lunar surface, going 10 centimeters at a time, bringing up some samples of the moon, that regolith, that then the mass spectrometer will study. Also on board that lander that's going to be touching down, if all goes well, in 17 minutes and 12 seconds, are the MAP rover from Lunar Outpost, which features communications technology from Nokia's Bell Labs. And not only will Nokia be testing out a 4G LTE connectivity demonstration between the rover and the lander, but also the lander and a hopper, micro version of the Nova Sea lander that's called Grace, named for Admiral Grace Hopper, a brilliant mathematician who served in the US Navy. Of course, we'll continue to monitor the touchdown of Intuitive Machines' Nova Sea lander and provide you updates on our social channels. But for now, we're going to go ahead and pivot back to focus on the Ariane 6 rocket. We're T plus 49 minutes, 36 seconds and counting. Just about 7 minutes, a little less than 7 minutes now, till the ignition of the Vinci upper stage, coming up at T plus 56 minutes, 21 seconds into flight. Now T plus 50 minutes, 46 seconds and counting. Our friend Frederic Castell is joining us back once again. And Frederic, obviously this mission is an important part of the CSO program. Can you elaborate on how this satellite is going to be working in concert with the other two that are currently on orbit, and just what this mission really means as far as the defense of France and its assets, as well as those of its allies that this satellite constellation will be benefiting? Now on your screen is actually a launch replay of the liftoff of this mission just a little bit ago. As we continue progressing towards the ignition of the Vinci upper stage here coming up in the next few minutes. Now T plus 53 minutes, 29 seconds and counting. Just about 4 minutes away from the start of that burn.
Sorry for the technical bug. We are saying that this third satellite is developed by Airbus and Thales Alenia Space. Is the state of the art in terms of observation, with this possibility of to be very agile and to have very different angle when it takes pictures of its objective on the ground, and then it builds up within minutes a 3D image which can be downloaded in France through Toulouse. But now this program, which started, the CSO, which started in 2018, is so successful in terms of quality that one after the other, at the beginning there were only two or three countries like Spain and Italy joining the CSO program on a bilateral contract with France. And now it's so successful that 8 countries are have a contract with France and are using CSO. That's why when I was in Kourou a few days ago, you had the generals of so many countries around Europe expecting to see the launch, and especially because they are using, they will use the satellite more and more with the 2 others. They can choose at request at the French Defense Ministry a target, and then we'll get the pictures within hours or within days according to the priority. And generally speaking, France is a leading force in terms of Space Force. Thanks to President Macron, a Space Force has been created in Toulouse. They will open a huge headquarters in the fall of this year, but already hundreds of engineers, space experts are joining this Space Force, which is under the authority of air and space forces in France, and that is very, very important. It's a little bit like what they did in the US, and now other countries in Europe also have their division of with the Space Force, especially with different satellite telecommunication, electronic, also surveillance and observation.
And just want to note here, as folks may have noticed on the screen, the upper stage engine has reignited for the start of its second burn. Now T plus 56 minutes, 45 seconds into flight. We are also now a little less than 10 minutes away from the deployment of that all-important CSO-3 satellite.
So things seem to be working pretty nicely. But in French Guiana, at the control center, everybody is, of course, very quiet, because the key moment, of course, is the release of the satellite. Until this moment, everybody is happy, but not fully sure that things will work. Space is always a dangerous environment, and you have some technical failures which can happen at any point.
Well, Frederick, thank you so much for taking the time to be with us for this broadcast. Really appreciate your expertise and insight, and always enjoy talking with you about all that's going on in European spaceflight, and especially the Ariane program.
Thank you very much, Will, and good luck with the rest of this mission.
Yes, hope for successful deployment here coming up in the next few minutes. And in fact, barn burner of a race here as we've got two very key mission milestones happening almost simultaneously. I want to bring in our split screen here because as you can see, we've got the landing of Intuitive Machines Nova C lander now 7.5 minutes away from touching down on the moon's surface, and at almost the exact upper stage of the Ariane 6. So barn burner in spaceflight for both deployment and touchdown. So it's a very happening moment right now in orbital spaceflight. Once again, we are a little more than an hour and a minute past the liftoff of the Ariane 6 rocket, less than 5 minutes to go for the deployment of the CSO-3 satellite. And as you can see, coming in from NASA and Intuitive Machines, the IM-2 lander now just a little bit more than 4 minutes away from its planned touchdown on the surface of the moon. Lots going on. Let's go ahead and dip into these final few minutes ahead of the landing of the IM-2 mission. And we'll, of course, keep these both up. So we're going to continue monitoring the progress of both flights and let you see them happen simultaneously as they happen virtually simultaneously.
Plan. There's LOS as we approach our pitch over. All right, we're approaching 11 minutes into the burn. Local time is 11:26.
AOS on Quasonics.
11 minutes in.
11 minutes in, we heard another call out that we're up on Quasonics. That's a radio system. It's 11:26 local. I'm looking at a pitch over time at 11:27 in about 52 seconds. So we are coming up over to the pitch over where we expect to have some loss of comms. Earlier we talked about multipath. That is very unique to the lunar South Pole, where our radio signals are using multiple ways to get to the same destination, whether that's from bouncing off the harsh terrain or some different polarity issues down there on the South Pole. We expect to have a weaker than normal signal, but we still want to make sure we get that confirmation, Leah. As part of that confirmation, we're going to safe the vehicle, figure out the status there, and then start working on pictures after everything's safe. Maybe around 2 hours after landing, we can cherish that photo.
LOS on Quasonics.
There's that loss of signal on one of the radio systems. We approach 12 minutes into PDI.
Again, the engine will continue to fire, albeit it will continue throttling down as we approach the lunar surface. And a reminder, the VIS is a simulation based on flight data, but if we do lose contact with the lander, which can be expected based on the conditions at the lunar South Pole, we will continue to see projected data on this visualization.
And we're approaching G, as in ground, to 2 minutes. We expect to drop this clock here in 2 minutes and take all of our commands from inside of Nova Control. The bottom right hand of your screen, that's Dr. Tim Crane, our co-founder and Chief Growth Officer, also sitting in as Mission Director for landing this IM-2 mission. Standing by for the latest information. Let's wait one.
Quasonics AOS.
HRN, HGA, HGA2.
Thales AOS.
60 seconds left in braking.
60 seconds left in braking.
And approach. Landing site selected.
Engine at idle.
11 meters cross range, divert.
Quasonics LOS.
There's that loss of signal over pitch over. Stand by, see if we regain that signal. Remember, folks, the viz that you're watching at home is an estimation of data. It's doing its best. That's a lot of data coming from really far away. All commands and all confirmations
Initiated pre-divert.
come from our mission director at the bottom right hand of your screen.
We're also now less than a minute away from the deployment of the CSO-3 satellite.
Again, we are standing by, monitoring the VIS just as you are at home, along with Nova Control.
We are approaching approximately the time that we estimated Athena would touch down on the surface. We did hear a call out for a Quasonics LOS. That is our radio system, something we expect to happen at pitch over. That's prior to a vertical descent and terminal descent. That latest
How are
data
we doing on signal?
is what you're seeing on the viz. Why don't we go?
We currently are getting our uplink through Hemi 2, and we have a healthy AGC value, so our uplink is coming in strong for Thales. And then for our downlink, we have a strong EBNO at 17 on Goonhilly, and we are currently not seeing our Quasonics. So we are in Quasonics LOS.
All right, that's a
See our
Quasonics.
signal strong on the spectrum for Thales. I'm not seeing our Quasonics on our spectrum as of yet. FM, what mode are we in?
Approach 17. That's the last we've seen.
All right, so that's up on one radio, and they do have a loss of signal in the second.
Fido, I'm looking at the Sense-XL. Do you see the Sense-XL reading? Let me look.
That's the mission director detecting CF
I am
lander.
seeing a Sense-XL 1G.
So that was the mission director, Tim Crane, trying to figure out what is the vehicle sensing. It has two inertial measurement units on board. You can think of those as your inner ear. So when he's asking what is the sensed acceleration, that's what he's asking for, is what is that inertial measurement unit, that inner ear, detecting as far as acceleration.
And just want to quickly note, we had a good confirmation of the CSO-3 deployment from the Ariane 6 rocket.
Again, as we've mentioned,
Seeing celebration there in the left-hand
viz
box
here
from
is,
Control Center down in French Guiana.
interpretation of landing.
Yeah, let's
Still
go ahead and
awaiting
stay
confirmation.
on Nova control. Looks like the Viz is hovering. We can't.
Prop, what are you seeing on the engine?
The engine is still in idle at min thrust. We are still seeing chamber pressure.
So we're getting good data. We heard that we have one radio up, one radio loss of signal. We just heard that we
I'm
have.
seeing guidance solution for time to go as increasing. It's indicating to me that it is the onboard nav state is not decreasing in altitude. The good news, the HRN laser is now ready to fire.
So we heard that we have one good radio sending down data, one that has loss of signal. We have prop.
Standing by with a manual command for landed ops.
Yep.
No recommendation at this time.
Yep, we have prop telling us that we have good data. That was someone just commanding. We heard exec mode to go into this firing mode and someone standing by to get into our landed ops mode. I'll wait for Dr. Crane to confirm here. But if we're pulling down data, we'll see how this goes. Looks like Tim's about ready to jump on the loop and sort out what we saw on the Viz versus what the folks inside of Mission Control are seeing on their monitors. It's a good reminder, too, this public channel that we're listening to here in the studio, Leah, and what people are listening to at home, at the landing party at Lone Star Flight Museum.
All right, folks. I'm showing that we are sensing lunar acceleration. So we're on the surface. Let's evaluate.
All right, let's continue to evaluate. I hear we do have a picture from a portion of the descent. Is that right over there? All right, so that's a picture during braking, about 10 kilometers up from the lunar surface that we do have while we wait for a little more information.
We can confirm the engine is still running and therefore needs to be upright. If we were in a different configuration, the engine would have snuffed.
Okay, so we have confirmation. I believe that was from Con that says the engine's still running. This picture you're looking at, the 10 kilometers up during that braking burn, that powered descent initiation, that long burn that brought us 4,000 miles per hour braking burn. Incredible shot.
Yeah, that's what I'm saying as well.
All right, there's another view there. Looks like from this panel, we're looking at the garage. So that's Lunar Outpost Map Rover inside of that square right there, Leah. And this looks like it's probably about the same altitude, maybe about 10 meters above the surface. And one more here for everyone. It's about the same altitude there, maybe a little bit more exposure, but these
camera's still running in HRN mode.
These photos came down for us just a few moments ago. Wanted to share those before we jump back into mission control as flight controllers are looking at this dynamic situation and learning.
Yeah, go ahead and put us in landed ops. It looks like we're down. We need to evaluate that situation, and I'd like to get a picture.
As they say, picture didn't happen.
LOS.
So Dr. Crane's onto it right there. A couple
FM
things here, Leah.
3402 was acknowledged. AOS on Thales.
What we're hearing in our ears and what folks at home are listening to are not the only channels
Check your systems.
that mission controllers are working on. It's an engine shutdown notice. We'll see what comes out of this. But they're all on different loops having separate conversations. So all the information that we have, that folks have at home, isn't necessarily the exact vibe inside the room. So we'll stand by and listen in to see what we have here. I did hear Dr. Crane call out that they are getting readings for lunar acceleration.
We're moving to the post-landing court procedure.
All right, Spark, I'm going to start shutting some stuff off as soon as we can.
Copy. Can you meet me on my loop, please?
Feed lines are inerting.
All right, so if we have enough data to be inerting feed lines, that means the engine's no longer running. and it's a state to bleed off that extra pressure. This is part of that safing bit that we talked about earlier, Leah. Looks like our CEO, Steve Altmus, just stepped into the room. That's in the bottom right hand of the box here, talking to the mission director, Dr. Tim Crane. He just called out telling Spark to turn some things off. That's because we need to remain in a power positive state, Leah, getting that top deck solar array into a spot where we are able to charge, but sometimes you have to turn a few things off to make sure that you're charging and not just burning through that power. All right, by my countdown clock, it's been about 22 minutes since we started that PDI, Leah.
And again, we were anticipating landing at about 11:31 a.m. Central Time, 12:31 p.m. Eastern Time. It can get tricky with communications on the lander when you're in a...
Prop, do we have insight to tank pressure if we turn off the Mogies and the Iggies?
We would, yeah.
All right, that's code for the...
If you turn off Mogies, then we cannot inert or vent the tanks.
Yeah. We can bring them back up though, right?
Yes.
How are my pressures?
They're low at this time.
Okay. Turn off the Mogies and the Iggies. Going.
Could we turn everything off except the vent valves?
Yes.
That would be everything except MV103 and MV303.
All right, all this activity is regarding the lander's propulsion system. They're going through deciding on how to vent it. We heard two things there, Leah. We heard Mogies and Iggies. That's our motor engine gimbal system, right? And our Iggy is our igniter. So they're working through the process of safing this engine. At the top of the show, we talked about the priorities after touchdown, and being safe was first, followed by pulling down some health status information, and then images. And then just about 3 minutes ago, we heard Dr. Crane go ahead and say,
FM3403 acknowledged.
We'll prioritize images. It's just about 9 minutes after the expected landing. So let's hang tight and continue to watch this problem and challenges unfold inside of Mission Control. Each one going through, finding this challenge, each one getting solved here. It sounds like they're still working through venting the engine system.
Let's power off the Quasonics until we get a handle on what antenna we're going to pipe it through.
Copy. Quasonics is currently in idle mode.
Good enough, thank you.
Quasonics, that's our radio. There's two radio systems on the lander. It sounds like when we talk about that vehicle health status, we heard some things for prop. Vehicle health status includes being in a power positive state.
Spark 636 acknowledged.
So we are communicating, commanding the lander, and getting acknowledgments back that the lander is behaving as expected. So putting those things together while we wait for confirmation from Dr. Crane. We have an engine that is shut down. We are venting the engine.
Spark 637 acknowledged.
We are getting acknowledged commands from the lander. Standing by for confirmation from Dr. Crane.
And just a recap of some of the timelines so far today, we had power descent initiation start about 25 minutes ago.
FM3406 acknowledged.
Power descent initiation is the braking burn that really committed us to coming down to our landing site today. We were targeting landing at about 11:30 a.m. Central Time, so about 10 minutes ago now. Again, still just standing by for some confirmation from the teams in Nova Control and hopefully a picture that shows the status of Athena on the lunar surface. Landing site today is Mons Mouton. It is the furthest south target for any landing up into this point.
And pretty credible images we just went through, you know, for those to come down during
Spark 638 acknowledged.
During that landing sequence, showing during that deceleration burn, just about 10 meters, I believe that was, over the surface for those images. Let's see who we have in there. Yep, down towards the bottom right-hand side.
Spark 639 acknowledged.
Of your screen, we keep hearing those acknowledgments of the vehicle receiving our commands as we stand by for the real deciding factor here. Never a dull moment, Leah.
And we did hear that they were going into
Spark 640 acknowledged.
Commanded landed ops. So can you walk us through some of what that means? I know that includes safing the engine as well.
Right, so there's different modes that we need to command, right? At the beginning of PDI, we hear the command for exec mode, all right?
Spark 641 acknowledged.
That's executing the burn maneuver, right? When we switch over into landed ops, it's a different setting on the lander in order for us to go through those steps, safing the vehicle first and foremost, that liquid methane, liquid oxygen engine.
Yeah, bring it down. Also, FM, I'd like a recommendation on whether or not we keep Talos 1 up or if we bring it down.
It's going to be a decision on up and down for radios based on
bring it down
power.
for now. We're taking the same pictures.
I would not recommend powering down Talos.
He did say pictures.
He did say pictures, yes. So, hoping to see the status of Athena on the lunar surface soon. We were initially expecting pictures would take a couple of hours to come down as the flight teams prioritized downloading data and safing the vehicle, but this will help us better understand the configuration of the lander.
Spark 642 acknowledged.
Every time we hear Michaela come on the tunes
Porter,
there,
can you zoom in on this view? Actually, give me the spacecraft view.
Spark 644 acknowledged.
getting all these acknowledgements coming through.
No, take task down.
All right, we're going to see here. Looks like Tim's
Star
got a good
tracker's
spot.
down.
Keep powering down things that we're not using anymore. Mission director looks like he's looking up at the screen. Maybe they're looking at a little bit of data that we do not have in front of us. Still standing by for confirmation. But we've heard a few steps go through the process, venting the lander's system, hopefully pulling down data inside of mission control, confirming Athena's status on the surface. And then finally, it sounds like we've heard a couple mentions of pictures. We've shown a couple from that descent stage. And we're just going to keep standing by, looking into Nova Control here in Houston, Texas, just down the street from Johnson Space Center, to find out the situation inside of the IM-2 mission with Athena's touchdown. Again, that was about, nominally, the touchdown time is about 14
Spark
and a half
645
minutes ago.
acknowledged.
We're still in contact with the vehicle right now. We know the vehicle has shut down. Its engines are powered down. We are getting acknowledgement transmissions to the vehicle.
All right, team. Keep working the problem. We're shedding power as fast as we can to keep the vehicle in good health. We are generating power. We are communicating through our telemetry radio, and we are working to evaluate exactly what our orientation is on the surface.
Spark 646 acknowledged. Spark 648 acknowledged.
So good confirmations there, right? We know we're getting acknowledgement. We're sending things to the vehicle. We're safing the vehicle. Now it's time to start
Spark
working the challenge of
647
how
acknowledged.
is the vehicle, which way is it pointed. Earlier in the show we talked about the different antennas on the vehicle and trying to work those, but we are charging, which is a very key element to this mission. Looks like the room's filling up with our subject matter experts. Just continue working on this challenge to see where we stand.
Spark
Bring them back down.
649 acknowledged.
If you see
DS is back in low rate.
You see folks walking on the bottom right hand of your screen underneath the camera. That's because the room's situational awareness is about a 65-inch TV sitting underneath of there. So what they're pointing at could be data, could be confirmation. A little hard to see from this view, but as you see people exiting the bottom of your screen on the bottom right, there's a television monitor there that's helping them make some decisions. And as we cross over, it's been about 30 minutes since time of ignition for PDI, and we just hit 16 minutes since our nominal landing. If you're just joining us, we know we are sending commands to the vehicle. We have shut off equipment that has not been necessary. We know that we have an engine that has been shut off. We've commanded the vehicle into surface operations. We just heard from Dr. Tim Crane that we are generating power. We're turning things off that are no longer required. We heard one of them being the star tracker. It's one of the tools that we use to figure out Athena's position in space during flight. We're in landed ops. Now we're just standing by to hear what the full situation is. About 16 and a half minutes since nominal landing time, and a little over 31 minutes since Athena commanded her final engine burn.
Spark
PDI.
651 acknowledged.
And like you said, Josh, we are
Porter,
communicating.
go ahead and turn on the displays for all the antennas.
We're communicating.
So you're going to see everyone looking up at the screen here. So when they're calling back to order, that's actually
Spark 652
in the
acknowledged.
back left of the bottom right monitor. They're changing screens inside the room, situational awareness television up front, right in front of the mission director. You just asked to pull up the antenna configurations, trying to figure
Spark
out
653 acknowledged.
which one's pointing back toward Earth, which might be the best one to use. Towards the top of the show and during PDI, when things got a little spicy, we talked about multipath, Leah, and that's something that we expect to happen on the South Pole. It's something we learned from during IM1, quite frankly, with Odie. Being on the surface and radio waves taking multiple paths to get to the same destination. Multipath exists down on the lunar surface just because there are so many different ways. So during IM1, we were sending out signals that were bouncing off the surface, bouncing off of craters, and making their way back to Earth. We took I think it was a Saturday and a Sunday to learn a little bit more about the multipath situation. You mentioned, Leah, Odysseus ended up breaking a leg and then laying down gently on the surface, but that communications does create a problem between multipath and learning about those things. Inside of Intuitive Machines' Lunar Data Network, it's comprised of ground stations all over the globe, the largest one of them
good
being...
work so far. What else we got?
The largest one's down in Australia. That is the Parkes Observatory. They call her Miri Yang down there, but that really is what helped us pick up those weak radio signals for IM1. That's not the dish we're on right now, but it seems like we do have a great connection from the vehicle. I believe that dish we're using right now is GHY6 in Goonhilly, but I don't have that confirmation right in front of me.
AD, this is Prop. Can you confirm what is getting powered down?
Everything we can right now, Prop.
Copy.
They're powering down these systems aboard the lander because it does take quite a bit of energy to land, but we did hear good confirmation that we are also generating power.
Yeah, all these commands that are going to Spark is code for avionics, right? It's where our power is being allocated on the lander. And we've heard a lot of confirmations of things being turned off. We heard Dr. Crane say we are generating solar power. At last check, we heard Mission Director call out to look at the antenna configuration on the room's situational awareness model screen, and we're still standing by to see where this is going to go.
Yes, power down the cosonics until we're ready to use it.
And folks, we're going to go ahead and end our coverage here on the Ariane 6 mission, since that has now been complete. We are going to continue tracking the progress for the IM2
20 minutes now since our
lunar
landing time
We are
today.
switching
Again,
that
we were
over
expecting
to
that around
Launch Pad Live, so we'll
11:30 a.m.
be
Central.
back with you, and you can follow that coverage picking up simultaneously right now. But we're going to go ahead and end
Teams in
this
the room
dedicated
with Nova
stream.
Control,
We'll see you over on
that's
Launch
here
Pad
at
Live
Intuitive
in just a
Machines
moment.
in Houston, Texas, just down the street from
Thanks
Johnson
for
Space
watching.
Center, continuing to evaluate the status of the spacecraft. Continuing to communicate with the spacecraft itself.